with all together, you're just going to get some big mess. WordPad, by contrast, if familiar, knows about just \n. So long story short, we'll come back to that with web programming. But for now, we're taking advantage of this as follows. \r has the effect, conceptually, of moving the head the printing head back to the left without doing what? Moving to a new line. So it just moves the printing head back to the left. So the effect now is that on every iteration, I'm going to reprint %complete : and then a number. But because I'm printing the same exact words and only changing the number, we have sort of a nice simulation of animation here. If I make progress2 and run now progress2, notice that we actually have a fairly pretty looking implementation now of a progress bar that's still a little slow for our tastes. But now we're exercising more control over the screen. Now, can we do a little better here? This last version of progress, if I go in here down to progress3.c, notice that I can do this also in a different way. So how am I doing this differently? Before I did a for loop. And frankly, I would say 8 times out of 10 when I write loops in any programming language, I typically, by default, use for loops. Even though they're a little uglier, they let you express yourself a little more succinctly. But we can do this otherwise. I could declare I as an int up here. I can then say while I is less than or equal to 100. And then what do I have to do? On each iteration, I can actually manually increment I with this ++. So again, I would actually argue this is a little messier of an implementation. Because look, I have I at the top. I've got this I++. And again, recall what I did a moment ago. This just feels a little more compact. Everything's more tightly knit. But again, this hammers home the point that you can implement these things in many different ways, just as in Scratch, with different pieces of puzzle pieces. Any questions? Yeah. Uh-huh.
Will it show 300%? Like when you go back and
Oh, yeah. Say it once more.
Will it show 300%? Or does it like erase the
Oh, good question. So I'm actually kind of cheating and making this seem a lot easier than it is because the numbers I'm printing are actually going up from 0 to 1 to 2 to 3 to 100. They're getting bigger. If we actually count it in the other direction, you can see what would happen here. Let me go back to progress2. Let me actually initialize this to 100. Let me go ahead and say this should do this while I is greater than or equal to 0. And what do I want to change this to? Minus minus. All right. So same idea, just slightly different syntax. Let me recompile this. Let me rerun it. And now you can't quite see it because my cursor's there. Let me rerun this again. I'm going to cheat just so you can see what's going on. I'm going to put a couple spaces at the end so that my green cursor is not overlapping. So if I rerun this, now notice that, oh, that actually fixed. Oh, I can't do that. I just fixed the problem by adding those spaces. All right. So we're going to have to look through my green cursor here to see this in this particular program. So notice what's happening. If the projector cooperates, that's a bug, right? So the green cursor is just an artifact of the GUI program. But I should not still have a % there, but I do because why? The number used to be 100. Now, if we and there was thus a 0 previously there. And so now we have a % overriding part of that big number, but not all of it. So if we let this actually go down monotonously down to 987, we'll see what also? Yet another % sign. So in short, I kind of cheated here to make it seem easier. But we could fix this, obviously, by just hitting the space bar or some other trick. But by default, the line is not erased. It only prints out what you tell it to do. All right, why don't we go ahead here, because it's a lot to digest. Why don't we go ahead and take a 2-minute break. I'll let this count down, play some music, and then we'll resume. All right. We are back. So as promised, bug, 3% signs was not the desirable outcome. Know that we could address this in a couple of ways. One, there's the slightly hackish approach where I just hit the space bar a few times. But you can actually do better. And just to plant a seed, know that just as with %f, where you can specify how many numbers should follow the decimal point. Also with %d, you can do what's called specifying the width of a number, how many spaces it will take up, even if it doesn't need that many digits. So long story short, know that with printf, for which there's documentation online that I'll pull up in a moment, there are these additional format codes and tricks so that you can tell printf, make sure you're using at least this much space, even if you don't need it for the size of the number. Yeah? And the f+2 is the other loose end here. So in general, when you call printf, what's really happening is you're handing a bunch of characters to the operating system and saying, please print these to the screen. However, for efficiency reasons, slightly historical reasons, the operating system typically will not display those characters on the screen until it actually receives a \n as well. The idea being, years ago, it's kind of expensive computationally to print a character. So the operating system wanted to wait and do a whole bunch of them at once. Obviously, in this program, I want it to print without using a \n. So fflush, which stands for file flush, this just means it's a message to the operating system saying, please, whatever I sent you, just print it now, print it now, print it now. In general, you don't need to do that, because in almost all of our examples, we've actually used \n. So this is a rarer case, but good to at least remember here. So in terms of documentation, you'll see a couple of things in the weeks to come. First of all, know that built into Linux and built into this command line environment is what's called man pages, manual pages. So that almost always, if you want to look up some technical details, you can type something like man printf for manual printf. And what happens once you hit enter is you get back a list of instructions here. And actually, this one's slightly a corner case. Let me do this. Man in chapter 3 of printf. And notice what I get. The Linux Programmer's Manual. And this is a little overwhelming, frankly, at first glance, which is why we'll show you a more user-friendly version in a moment. But long story short, this documentation, which we'll come back to later in the term, tells you, one, under synopsis, what header file you need to use this function. It mentions related functions. And these we won't get to for a while, and not even all of them. But printf, fprintf, sprintf, turns out there's a bunch of them. But if you ever want to know the precise definition of something, even if it's way more information than you care to know, it's almost always in these so-called man pages. Now, when we want you to look at here in PDFs of the problem sets, we'll generally tell you what to type, man something something, so that you don't need to go around guessing. But know that in the meantime, frankly, the more user-friendly thing to do is if you go to cs50.net and click resources, what you'll see on this page is a bunch of recommended resources. These are the free alternatives to the recommended textbooks, and typically, based on the week, we'll expand different parts to just draw your attention to things that we think would be useful. In particular, this one up here, C reference. Again, on the resources page, this is a fairly simple website that actually has much more user-friendly documentation for a whole lot of functions. Sometimes you have to kind of know what you're looking for because they're categorized here on the left-hand side. So I don't see printf immediately, but I do know that printf now is related to input and output, otherwise known as I/O. So if I click on CIO, there's a whole laundry list of functions we've never looked at, and most of these we won't even bother. Because you don't need to know all functions to make good use of a language. But there's printf. And if you scroll down here, OK, anything that says Bob is probably fairly user-friendly. And indeed, this is slightly more accessible descriptions of how it works. Now, some of the syntax we haven't gotten to just yet. But notice in this purple box, it's telling us standardIO.h. It's telling us that printf, and we'll come back to this, returns an int, even though we're not using this yet, just like main, and it takes a const char format, comma, ... So when in doubt, just kind of ignore for now things that you don't quite understand, but look for the examples in particular. And down here, you'll see a chart of all of the available format codes. We've talked about %d, we've talked about %f, but it turns out there's a whole bunch of others. And generally, only a few of these do you need, but know that this documentation, the C reference on cs50.net, is a wonderful place to start when you have questions, as well as any of the books that you might be dabbling in. So a few FYIs. One, typecasting. So typecasting is this notion that we saw earlier of converting one type to another. But it's actually more useful than just these simple things of ints to floats and the like, because one of the domains we'll be focusing on this week is that of cryptography. And for those slightly familiar, what is cryptography in English? Coding, yeah, so it's the art of encrypting or scrambling information, right? So back in grade school, if you wanted to pass your crush a secret note and you wanted to hide it from the teacher, you might say like some message, but then you might rotate all of the letters by some number of places. So if you wanted to say the letter ABC to your crush, you would say BCD or something simple like that, but enough sufficiently complex that when the teacher grabs the piece of paper from you and intercepts it, it's not clear what it is unless he or she actually tries to decipher the actual encryption you were using back then. Now, thankfully, fast forward to modern day, you can do much more sophisticated things, and encryption is something we take for granted. Anytime you buy something online, every time you log into Facebook using HTTPS and ward off Firesheep and all of your friends trying to hijack your account, you're using encryption. Even things like the 33% of you with iPhones and 70% with Androids. Typically, the iPhone these days is automatically encrypted with a secret key, and so if your phone is ever lost and you enable that feature called remote wipe, where you can send a message to Apple and they can send a message to your phone that says delete it, all the phone is doing these days is just forgetting that secret key, and without that key, all it looks like is random zeros and ones to the bad guy that just stole your phone. So there's a lot of applications, just to very useful consumer things, and we'll introduce this weekend in problem set 2, this art of cryptography. And it pertains to a little something called typecasting in this case. I'm going to go ahead and open up ASCII1.c, another example that's been pre-prepared here that apparently does this. We've got a loop at the top, a for loop, then we've got some printf, then another for loop. And notice inside of each loop, this is just for demonstration purposes, I've hard-coded the numbers 65 and 26. Well, 26 is probably the English alphabet. What was 65, if you recall from last week? Yeah, so capital A. So this is just a simple little diagnostic program I wrote to show me what the number equivalent is of every character on my keyboard, at least the alphabetical characters. So I seem to have a loop that is starting at 65. It's not 0, but it's totally legit to start somewhere else if it makes more sense. I'm iterating up to 65 plus 26, so that'll get me all the way to Z, hopefully. I++, and now notice what's happening here. I'm printing out %C, which is a character, then a colon, then %D, and what am I plugging in? Well, notice I'm plugging in I both times, but the very first time I am, quote unquote, casting it to a char, because I want to actually see I, not as the number it is, but as the char, the character it represents. So I might see A, 65, B, 66, and so forth. And then take a guess here, 97 represents what? Lowercase a. So let's see this in action. So let me make this a little bigger. This is again called ASCII1. And ASCII, again, is just the acronym that denotes the code used to map letters to numbers and vice versa. So make ASCII1. Everything compiled OK. Let me go ahead and run ASCII. And indeed, it's a little long of a list, but if I scroll all the way back up, that's exactly what I had promised. So we can now see this conversion here. Now, what's the relevance? Well, again, think back to grade school. If you ever did send one of these silly notes, well, you had to rotate or convert letters to some other letters. Well, how did you really do that? Well, you shifted them by 1. A becomes B, B becomes C. But how do you express that? If you want a computer to do it, and do it way more sophisticatedly than a small kid could, well, you probably want to convert the letter, like A, to a number, then do your math, like +1, and then convert it back to a letter. Well, we already have that capability here. Let me go ahead and open up a variant of this. If I go and open up ASCII2, we'll see this. In ASCII2, I'm doing something a little prettier because it got a little overwhelming to have it all display on the screen. So again, just to mention that format code I mentioned earlier, %3D means no matter what, use 3 characters here to represent a number and just prepend it with white space, just the spacebar character automatically. So what is this going to do? Well, this is just a different aesthetic. I'm going to go ahead and make ASCII2. The code is almost exactly the same. And then I'm going to run ASCII2. And what happens? Well, now I just get a chart. So again, fairly simple aesthetic modification, but it's a little more user-friendly now. But I wanted everything to line up. So notice again, %C, %D. But notice on the right-hand side, I actually said %3D. Why did I use 3D, do you think, for the third column and not for the first? OK, I couldn't make any of that out. But yes, I was probably correct. Right? It's because the numbers in the third column there actually are 3 digits potentially. Yes, you start at 97, 98, 99, but then you get 3-digit numbers. But for the capital letters, it was all single digits. So I could have said %2d, but it wasn't necessary because I know they're all going to be 2 digits. But that's all. So we're just now massaging the output aesthetically by using these disparate format codes. Well, let's see if we can't do something a little more interesting than just print out these letters.